Now we shall solve the second problem. Here second problem is that two equal chords AB and CD intersect at P inside the circle whose center is at O. We have to prove that AP equal to CP and BP equal to DP. Here two equal chords AB and CD intersect at P inside the circle whose center is at O. We have to prove that AP equal to CP and BP equal to DP. Now we shall draw the figure of the circle. Here we can draw the circle. This is the circle. This is the circle. This is the circle whose center is at O. This is the center O. This is the center O. Here two chords, equal chords are drawn. These are two equal chords. These are two equal chords. Here these two chords are AB and CD. These are two equal chords AB and CD. These two chords intersect at the point P. Intersect at the point P. These two chords intersect at the point P inside the circle. P is inside the circle. We have to prove that AP equal to CP and BP equal to DP. Here O is the center of the circle. Now we can draw two perpendicular OM and ON on AB and CD respectively. We can draw two perpendicular from the center O on AM and CD respectively. We here we have drawn OM perpendicular to AB and ON perpendicular to CD. We have drawn two perpendiculars which are OM and ON on AB and CD respectively. Here also we are given AB equal to CD. Here also AB equal to CD because these two chords are equal. Here two equal chords are given which are AB and CD. AB equal to CD. Length of these two chords are equal. Now we can start the proof. Here we can also draw before starting this proof, we have to draw OB. We have to draw OB. That is, we have to connect O and B and O and D. And also we can connect BD. We have also connected O and B and O and B and O and D. connected O and D, and also connected B and D. B and D. We have connected O and B, O and D, and B and D. These are connected. O and B is connected, O and D is connected, and B and D is also connected. Now we start the proof. Here you can see that two triangles are formed. First triangle is OMB and second triangle is OND. From these two triangles, from OMB, triangle OMB and triangle OND, we get OB equal to OD. OB equal to OD. OB equal to OD, and BM equal to ND. BM equal to ND because AM equal to BM and CN equal to ND, because AM equal to MB and CN equal to ND, because as OM perpendicular to AB and ON perpendicular to CD. OM perpendicular to AB means OM bisects AB, and ON is perpendicular to CD means ON bisects CD, because OM is perpendicular drawn from the center of the circle to this chord, and ON is also a perpendicular from the center of the circle. A perpendicular from the center of the circle is drawn to this chord CD, so ON bisects CD. We have already known this from a theorem. So OM and OM both bisects AB and CD respectively. So we can say that AM equal to MB and CN equal to ND, and also AB equal to CD. We are given AB equal to CD, AB equal to CD, AM equal to MB, CN equal to ND. So we can say that BM equal to ND and AM equal to CN. AM equal to CN. AM equal to CN. That is, these are two equal parts of AB, and OM divides AB into two equal parts, AM and BM, because OM is a perpendicular drawn from the center of the circle to this line, to this chord AB. So it bisects AB, that is, it divides AB into two equal parts, which are AM and BM, that is AM equal to BM. And also ON is perpendicular, ON is a perpendicular drawn from the center of the circle to this chord, so ON bisects CD, so CN equal to ND, that is, ON divides CD into two equal parts, CN equal to ND, that is, ON bisects CD, so CN equal to ND. Now AB equal to CD, so we can say that BM equal to ND and AM equal to CN, because AB and CD are two equal chords and they are divided into equal parts at M and N. So each part are equal to the other part of the chord. Each part are equal to each other, that is Bm equal to Nd and Am equal to Cn, because these two chords are equal to each other, and M is the midpoint of AB and N is the midpoint of CD. So, each part of AB and each part of CD are equal to each other. So, you can say that Bm equal to Nd and Am equal to Cn. Am equal to Cn. So, we can say that these two triangles are congruent to each other by RHS property. So, and also OMB, we can say OMB equal to OND equal to 90 degree, because OM perpendicular to AB and ON perpendicular to CD. So, OMB and OND both are 90 degree. So, they are 90 degree. So, by RHS property, we can say that these two triangles are congruent to each other by RHS property. So, triangle OMB congruent to triangle OND by RHS property. By RHS property, we can say that these two triangles are congruent to each other. So, we can say that OBM, so OBM equal to ODN, because these two triangles are equal congruent to each other. So, these two angles are equal, will be equal. Now, the triangle BOD is isosceles. Now, triangle BOD is isosceles. Triangle BOD, that is triangle BOD is isosceles because BO equal to DO. Why BO is equal to DO? Because they are both the radius of the circle. BO and DO are the radius of the same circle. So, BO equal to DO. BO and DO are the radius of the same circle whose center is at O. So, they are equal to each other. So, BO equal to DO, because BO equal to DO, the radius of the same circle So, they are equal, BO equal to DO. As BOD is isosceles, so these two angles are also equal, that is OBD. So, angle OBD equal to angle ODB, because BOD is isosceles triangle. BOD is an isosceles triangle. BOD is an isosceles triangle. So, these two angles are equal, OBD and ODB. So, we can say that MBD, angle MBD, that is angle MBO plus OBD, we can add the right hand side and left hand side of these two equations, that is OBM equal to ODN and OBD equal to ODB. We can sum of the right hand sides of this equation and we can sum of the left hand side of these two equations, and also we can also sum of the right hand side of these two equations. By summing up, we can get MBO plus OBD equal to MBO plus OBD equal to ODN plus ODB. So MBO plus OBD, you can see that MBO plus OBD is the angle PBD, angle MBD, that is the angle PBD. So you can say that this summation can be written as the angle PBD, that is angle PBD equal to angle ODN plus angle ODN plus angle ODB is also angle PDB, because this summation is the angle NDB and NDB and PDB are the same angle. So you can say that PDB in place of ODN plus ODB. We can write PDB in place of ODN plus ODB, because if we sum up these two angles we can get the angle PDB. So this is PDB, this is PDB, this is PDB. So we can say that PBD is an isosceles triangle. So triangle PBD is an isosceles. So we can say that PB equal to PD. We can say that PB equal to, so PB equal to PD. Now AB equal to CD, we are given the two equal chords AB and CD. So AB minus PB, you can write AB minus PB equal to CD minus PD. We can write AB minus PB equal to CD minus PD, because PB equal to PD and AB equal to CD is given. So we can write AB minus PB equal to CD minus PD. Also AB minus PB is AP. This is AP and this is CP. So these are two proved. Firstly we have proved PB equal to PD, and secondly we have proved AP equal to CP. So we have proved AP equal to CP and BP equal to DP, where two equal chords AB and CD intersect P inside the circle whose center is at O. We have proved AP equal to CP and BP equal to DP.